Hi, I'm going to be doing problem number 33. The problem is, objects with masses of 200 kilograms and 500 kilograms are separated by 0.4 meters. A. Find the net gravitational force exerted by these objects on a 50 kilogram object placed midway between them. And B. At what position, other than infinitely remote ones, can the 50 kilogram object be placed so as to experience a net force of 0? So over here, I've already drawn my picture. I have my 200 kilogram object, 50 kilogram object, and 500 kilogram object separated 0.2 meters. And A is asking for the gravitational force. So I've already written down my equation, and I'm just going to plug in what I know. So G is the constant. M1 I have as 50 kilograms. And M2, I'm going to subtract my 200 from my 500, so that gives me 300 kilograms. And at the bottom here, I have 0.2 meters squared. So once I calculate that, I get that the gravitational force is 2.5 times 10 to the negative fifth newtons toward the 500 kilogram object, which makes sense because of its heavier mass, it's going to pull the object closer, or more that way. Okay, so that's A. And then for B, I have, At what position other than infinitely remote ones can this object be placed so the net force is 0? So, in the case that the net force is 0, the gravitational force is going to equal each other. So I'm actually going to equal these equations, M1 and M3. I'm going to label this M1, this M2, and this M3. So yeah, over x squared equals 0.4 minus x squared. Oh, okay, this is the distance, and if this is the whole distance, then whatever this is, which is actually going to be closer this way, is going to be 0.4 minus x. So automatically we can cancel out the g's and the m3, so then we end up getting 0.4 minus x squared times m1 equals x squared times m2. And then when I FOIL this, I get that. And then I get x squared times 200 kilograms. So this becomes a quadratic. Plus 80 equals 0. Oops. So then I can reduce that. And this is not a fun-looking quadratic. So thanks to Diksha, I now know how to do this on my calculator. A is 30, B is negative 40, and C is 8. And you get two answers. You get x equals 1.088 meters, or x equals 0.245 meters. And we know that this can't be the answer because it is greater than the distance between them. So that just can't be right. And then this one is the correct answer, and it's 0.245 meters toward the 500 kilogram object. Okay, that's it. Thank you.